All right, in geometry, we're on lesson 10-4, circumference and area. You guys know the difference between circumference and area. The way that I think about circumference, if I had to explain it to a kindergartner, is if you were an ant that were walking on the edge of a circle, it is the total distance that you walk. And if you are talking about area, it's as if you're painting the inside. So if I have some amount of paint that I'm trying to figure out, it's the amount of paint that I need to paint the inside of a circle. That's the same thing as area. Do you guys know the formulas for circumference and area? I'm seeing a lot of people shaking their heads no. Valentina's thinking. Yeah, this kind of, you're missing a little bit in there. So let me go back to the history of where pi comes from, and then we can maybe get the answer to this one, and then maybe with the area as well. So what is pi? Does anyone know the first few digits of pi? 3.14. Say again, 3.14159. Can anyone beat that? I'm going to be doing a competition on Pi Day. Whoever can get the most digits, obviously you don't have to compete against me. I just tested my knowledge and I can get up to 35 digits. In the past, I've been able to get up to 70 though, so I'll train myself again and see if I can beat my previous high record of 70 digits of pi. There are things that are called pi poems where every single word corresponds to the number of letters. And if you can make me a pi poem, I'm definitely going to be giving you extra credit because they're really hard to make. Feel free to use ChatGPT or whatever it takes to make them. So a pi poem would be the equivalent of saying a word like, well, it's 3.14, so I'd say something that has 3 letters. I can say TWO has 3 letters, so this corresponds to the number 3. And then 1, I could do, I don't know, 2, yeah, I can't even make the poem come out correctly. To do 3 letters, I would say, there we go. Can I, 3.14, can I come 3.141 come a, yeah, so it's really hard to make a pi poem, but essentially every single number corresponds to the number of letters in a word. You can go out as far as possible. If you memorize your poem, you've kind of memorized digits of pi as well, so that's why I'm also offering the extra credit. So pi, if you did not know, is if you take a measuring tool and you measure some sort of circle and you measure the distance on the outside and you divide that by the distance across the circle, that's pi. So the way that we say that is that pi is equal to the circumference divided by the diameter. That is exactly pi, but getting exact values of this has been a problem throughout all of human civilization up until today. Now we have over 100 trillion digits of pi with a calculator or with a computer. So if I want to rewrite this formula, I could multiply both sides by d here, multiply by d, and notice what I've done. D is now gone, and I have a formula for circumference. Circumference is just pi times the diameter. So you can say that this is equal to pi times the diameter. Or if you don't like using the diameter because you like to have the radius and everything, you can also call this thing the same thing as pi times 2 of the radius. 2 times the radius is the diameter, so I can say times 2 times r, or more commonly, we just say 2 pi r. 2 pi r. That's the formula that I have memorized, and that's the one I would like you to memorize as well. For the area, you can't really prove the area with only using geometrical tools. You can get an informal proof that we can talk about later. There's a cool video that shows why area is equal to pi r squared. But notice that it's kind of the same letters. I have a 2, a pi, and an r. I have a 2, a pi, and an r. It's the same numbers and symbols, just in a different order and with a power. Kind of cool. And just a brief history of pi. So the earliest time that we modern humans know of as an approximation of pi is the most ancient civilization that I know of, the Babylonians. That's around 2000 BCE, before the Common Era. And they approximated it as 25 over 8. So their evaluation of pi is about 3.125. And of course, pi we know as, and again, you have to round this to 3.14159265335897923846264338327952. It goes on and on forever and ever. It is random. It is non-terminating, meaning it goes forever and ever, and there is no pattern to it. You just have to memorize it. So, of course, 3.12, they missed, they're correct to 1 decimal place, and they got really, really close to 4. So pretty good for 2000 BCE. Then we get to ancient Egypt, and they're thinking that pi was 16 over 9 squared, which is 3.16. Again, they got 1 decimal place of accuracy, still can be better. In 950 BCE, we have the Hebrew Bible that approximated at 3, which is worse now, so no good. Finally, Archimedes, he used a 96gon, so a square is a 4gon, a pentagon is a 5gon. Archimedes used a 96gon, drawing this in the sand. There were no whiteboards back then. He precisely measured it that pi was between 223 over 71 and 22 over 7. So he approximated it as roughly 3.1418. So he had 3 decimal places of accuracy, which is fantastic considering he was doing things in the sand. A little bit after that, in China, Louis Hui in 263 CE used a 192gon and got it a little bit more accurate, 3.146, still only 3 decimal places of accuracy. In India, we had Brahmagupta, I can say his name correctly, in the 7th century, so the 600s, and he approximated it as the square root of 10, which is less precise. But again, the world was not connected back then, so he was independently doing his own work and did not beat China. Then we have Al-Kashi, I don't know how to pronounce his name, but in Persia, in the 15th century, he got 16 decimal places of accuracy, which is insane. In class, we will not get to that level of accuracy by hand in I think we're going to be spending 3 days on this. And then we have Ludolf van Quillen. He got 35 decimal places of accuracy. In fact, he spent his entire life trying to find decimal places of pi, and he only got to 35 places. Some people at the time called it Ludolf's number because he spent so much of his life researching pi. Then we get to John Machen, and Machen is the one that uses the Machen's formula that we're going to be using. He invented that formula, and he got 100 decimal places of accuracy. We're using his formula because his sequence converges on pi super fast. And then we had computers in the 1940s that got up to 2,000 decimal places, and now we have over 100 trillion decimal places of accuracy. I think you only need about 50 decimal places of accuracy in order to calculate where atoms are in our observable universe. So they don't really need that many. It's just kind of flexing on the rest of the world on who can calculate the most digits of pi or who can memorize the most digits of pi. So yes, it's kind of, I didn't have to talk about the history of pi, but it's fun too. All you really need to know for this lesson are the circumference and area formulas to solve everything. So let's dive into an example that you'll be seeing on the homework. Find the area and find the circumference of that circle. So let's see, who has circumference memorized? Circumference. Eli, you've got it memorized? Uh-oh. Valentina? Exactly. So I'm going to say circumference is equal to 2 times pi times the radius. My radius in this case is, well, 12 is the diameter. So half the diameter is 6. So I'm going to say times 6 in this case. And the answer here is going to be 12 pi. So this is what's known as an exact answer because I use pi in my answer. That's the way that I would prefer my answers. But just to show how to use pi, if I go to some sort of calculator, let's go to like a scientific calculator. If I type in, here, let's go ahead and split the screen. If I split the screen like this, can you see? Good. Okay. So if I type in 12 pi, this is roughly, now I'm approximating, I'm going to do wavy equal to sign. This is going to be 37 point. And if I round to 1 decimal place, I'm going to say 0.7. But now this is an approximation. It does not have an exact value. We're okay with that. Okay. Now let's move on to area. What's the formula for area? Who has that one memorized? Go for it again, Valentina. Pi r squared. You guys have to have these memorized. They will come back over and over in all of your other math courses. So if area is equal to pi r squared, this is going to be pi times our radius, which we know is half of the diameter again, 6. And then I'm going to square that. So the area here is 36 pi. Again, on the calculator, you can approximate this using wavy to equal to sign, saying 36 pi, and we get about 113.1, rounding to 1 decimal place. So that's kind of like an easy, like 7th grade type of problem. So we're going to go a little bit higher in our class. So a little bit higher would be this one. Find the radius if the circumference is already calculated for us as 25.32 centimeters. Now there are units here, so we have to have units as well. How would I do this? Well, you use the formula. You can say the circumference is here is equal to 2 pi r. And I happen to know that this circumference is 25.32, so I can substitute u in to here, and I can say that 25.32 is equal to 2 pi r To isolate r, to find the radius, I need to do what to both sides? Oh my God, Valentina's doing all the heavy lifting. Valentina, I have to place a gag order on you because you are too smart. We have to let someone else have a chance as well. If you divide both sides by 2 pi, you indeed get r by itself. You can say r here is approximated because there's a pi in here. It's going to be 20, let me delete this. It's going to be 25.32 divided by 2 pi. And the answer here is about 4 I'm going to go to 2 decimal places of accuracy, about 4.03. And then how would I find the diameter if I have the area? Someone other than Valentina. What's our formula for area? What's our formula for area, Evan? Area is equal to base on site for a rectangle, yes, but for a circle, it is pi r squared. Very nice. Pi r squared. And we happen to know that the area is 100. So I'm going to plug in 100 and set this equal to pi r squared. Notice that when we solve for r, we will not be done. We'll have r, but we need the diameter. Our very last step will be to double whatever r is to get the diameter. So how do I solve this one? This one's a little bit tricky. What do I do to both sides? Someone other than Valentina. Well, no, we want to get r by itself, so let's move this over on this side. How do I move the pi over, Evan? Divide by pi, and I now have, I'm just going to leave this as 100 over pi is equal to r squared. I need to get r by itself, someone other than Evan, someone other than Valentina. How to get r by itself? Eli, you got it? He was about to raise his hand. He was like, yeah, just square root both sides. So if I go and square root both sides, the square root and square root, I get my answer. R is by itself, and I say r is approximated by the square root of this fraction of 100 divided by pi, and that answer is about 5.64-ish. Those are the types of problems that we'll be encountering. You guys have been warned, Pi Day. We are going to be manually calculating digits of pi, as is the custom. Are there any questions about today's lesson? Fist of 5 on those 3 examples that we did. 5, 5, 5, 4, 3. Huh? Cool. Thank you, guys.